Hi, my name is Mike Della, and we're going to talk about how to determine the rate law from experimental lab data for individual components of the basic rate law equation. And when I say the basic rate law equation, and this is, again, just to backtrack a little bit, this is for Chem 2. So the basic rate law equation is derived from here, and it's only worries about the reactant side, the left side. So we go back up here, we see that it's K times A raised to the exponent times B raised to the other exponent. A and B are expressed in moles per liter. And now to get the answer for A and B exponents, we are going to look at an additional problem. Okay, so let's go to the problem. This is the equation. 3B plus C yields E plus 2F. Again, just for repeating, with the rate laws, we only are concerned with the reactant side, which is the left side, and therefore to find the variation of C with respect to the data provided, you must select values that are identical in the lab data, and then the variation of C and associated changes in rates are due exclusively to C. What does that mean in English? We look over here and we see that to find C's variation, we find B and B in 1 and 3, which are identical, so the changes in the rates are due exclusively to the changes in C. Okay, so if that's the case, we now need to go and determine how we calculate this. We have the answer here, but we need to go to the next page to determine the calculations. Right, now we set up the following equation to determine the C exponent, which is this one. We take the concentration values of C from experiment 3 and the concentration C from experiment 1. Now, I got 0.50 and 0.250. Just as a refresher, this is 0.50 and 0.250, and we always want to have the larger number on top so that we don't have to look for what I would call negative exponents. Okay, so that's why that 0.50 is there. I mean, you can do it the other way, but it gets very messy. Again, the respective associated rates based on the experimental data are from that data, and they are 0.00100 and 0.000250. When we do the math, we get 2 to the y is equal to 4. Therefore, y is 2. Therefore, the exponent for the C variant is going to be 2. So the rate law right now is K times B to the X times C squared. Now we do the same thing and we look at the data. Again, we take a situation where C values are constant. So we are going to look again where if the C values are constant, we want to look at experiment 1 and 2. Okay. Okay, and then we have the same situation where we have the larger number on top, and then we get 2 to the x is equal to 2. Well, the only value of x, which will make that, is 1. So the rate equation is k is equal to b times c squared. So if we go back to our original answer, that is E. Okay, I'm going to give everybody a few minutes to digest what I just said. And we're going to do another problem, which is a little more complicated, in that it asks for some additional information. But again, remember the secret here is to look after the data in which one of the components is the same in both experiments. So it's either these two or these two in this experiment. And then we take the corresponding rates to make sure that we know that the changes are due exclusively to the change in one of those variables. Okay, so the next problem is this one right here. The reaction of butyl bromide with water is represented by the following equation. Okay, and it is balanced. Then we look at the following data and how it is tabulated. Again, this is the data in regards to the concentrations of CH3, CBr, experiment 1, 2, and 3. And now we want to go initially to the generic rate equation. What's the generic rate equation? The generic rate equation is going to be K times the exponent on the left side of the appropriate reactant, which is going to be here. Same thing for H2O, and we call it X and Y. And again, to solve for CH3Br, we look at a situation where H2O is the same. Okay, all right, so, and we take the larger number, which is 1 times 10 to the minus 1, the corresponding rate, we take the concentration, and we then divide, and we get 2 to the x is equal to 2. So in this case, x is equal to 1, and you don't have to write down the 1, it's understood. Now we do the same thing for water. We want to look for a situation where these values are constant, which are experiment 1 and 2, and then we do the same thing. We take and divide the larger by the smaller, and we get 2 to the y is equal to 1. Well, you know, the only way you're going to get that is that if y is equal to 0. Well, if y is equal to 0, then the rate law, let me go back here, is going to be this component, and in this case we don't have to have the component in there because y is 0 and anything equal to 0 is a 1. So we go to page 5, and now the next question is, what is the overall rate? Well, the overall rate is equal to the sum of the exponents, x plus y. Well, in this case it's 1 plus 0 is equal to 1. Therefore the rate is equal to just the CH3 3Br, and we do not have to write again the exponent 1 there because it's understood. Now to solve for K, we take and rearrange the equation. We pick, and here's the key, we pick any value from experimental data, 1, 2, or 3, with the corresponding concentration. If we did this correctly, it makes no difference, you will get the same value of K. That's because K is a constant. So in this case, we go to the experimental 2 data, divide that accordingly, and we get 4 times 10 to the minus 3rd as the answer for this one. Okay, so this is how we do this problem. Now let's just recap it. Okay, hang on 1 second. When I say recap it, this is the experiment we recapped. And they want to know what the order was. We got that. What is the order with respect to H2O? We got that. What was the overall order? Write the rate equation and calculate the rate constant K for the reaction. Okay, now that we've done a couple of problems, I'm going to give you 3 problems, and we will not work them out exactly. We will just give you the answers. So the first one is this one right here. We have the answer, and here's a hint. Examine the changes to see when A and B experimental values from 2 different experiments are respectively identical, so only change is due to C. Okay, and that's a big hint. And I'll give you one set of data. No, I think it's something that you best figure out yourselves. Okay, otherwise I'll give you the answer right off the top. Okay, the next one are these two problems. Okay, again. And the corresponding answers are, this is the answer for 2, and this is the answer for 1. So these are the answer keys associated with this problem. This is 1, this is 2, this is the answer key for 1, this is the answer key for 2. If you have problems getting these answers, please visit us in the ASC in person, or when we have a virtual session, bring the problems to the instructor, and we will work with you to get the right answer and to explain the differences. Again, this is how to determine rate law data from lab experimental data. And that'll be all for this session. Thank you very much.